Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet for chi-square and regression. And this is going to be problems 31 through 40, and it's focused on regression. For a specific species of fish in a pond, a wildlife biologist wants to build a regression equation to predict the weight of fish based on its length. All right. The biologist collects a random sample of these species and finds the lengths to vary between 0.75 to 1.35. The biologist uses this data from the sample to create a single linear regression model. Would it be appropriate to use this model to predict weight of fish of this species that is 3 inches long? Well, when I look, I say, hey, there's no, that 3 inches is not in that interval of data collected. That is longer. Because it is longer, it would not be appropriate. So no, it's not appropriate because 3 inches falls above the maximum value. We would need to be between 0.75 and 1.35 for it to be appropriate. 3 inches is not in there, so it's not appropriate. Okay, so that's that one. So now to 31. That was 31. Now to 32. A botanist found a correlation between the length of aspen length and its surface to be 0.94. Why does the correlation value of 0.94 not necessarily indicate that a linear model is the most appropriate model for the relationship between length of an aspen leaf and its surface area? All right, so the problem is correlation doesn't show that. What indicates that it's a good model is a residual plot. So even though 9.4 is very high, very strong, it's possible that a relationship could still be better by a nonlinear. And we need to check a residual plot to know that. So in this case, we need to check a residual plot to know whether or not that's the case. All right. As far as these other answers, it doesn't have to be 1 or -1. The value must be 0. If it's 0, then there's no relationship. Okay? A causal relationship should be established. Correlation does not prove causation, so that can't happen. Um, the value of 0.94 implies that only 88%. What they did here, at least what I think they did, we're about to find out, is they squared it, and it says 88% of the variation in width or can be explained by the length, but uh, that's not what it is. They don't have an 88% have the linear relationship. It's 88% of the variation in the surface area can be explained by aspen leaf length. 33. A food truck owner recorded the temperature at noon in degrees Fahrenheit and the number of bowls of soup sold during the day during the lunch hour for a random sample of 5 days. The data is shown in the following table. Okay, the mean temperature of the sample is 62 Fahrenheit and the mean number sold is 14. What is the correlation between temperature and the number sold? Well, the easiest thing to do with this is to put this in a stat edit, which I've already done. I put temperature in L1 and number sold in L2. And I went stat test and I want to run a linear regression t-test, which is F, L1, L2. I really don't care which one you choose right now. Then we're going to press, so I'm going to use not equal because that's what we're going to use most commonly, alpha trace. And if I scroll down, I get my correlation as negative 0.85. So the best answer to 33 is A. Number 34. A grocery store wants to examine the relationship between the sales amounts each day at two different locations, store A and B. The sales amount each day in dollars was recorded for 10 days at each store. And here's our least squares regression line. All right, where X represents for store A. So this is store A. And Y represents for store B. If the mean of the 10 amounts for store B is 45,000, what is the mean of the 10 sales amounts for store A? So basically, remember this, the Y is B and this is A. So we're going to write this down. Y hat equals negative 3,000 plus 1.2x. Well, I'm going to plug in B and A. So B equals negative 3,000 plus 1.2 times A. And then I'm going to go, oh, they said that's 45,000. So I'm going to scratch out B and write 45,000. All right. I'm going to add 3,000 to both sides and I'll have 48,000 equals 1.2A. And now I'm going to divide both sides by 1.2. When I take that 48,000 and divide by 1.2, I'm going to get 40,000. So my best answer choice for 34 is B. 35, a linear regression analysis performed on the data from two scatter plots A and B, resulting in an identical squares regression line with positive slopes. Which of the following statements is true? The sum of the squares of the residual in A equals the sum of the squares and residual of B. No, that's false. We can end up with our data. There's our same line. Well, this one could have data that's really, really close, and this one could have data that's really, really far. All right. In which case, yes, we have the same line, but the sum of the squares of the residuals are substantially different. This one will have more than this one. The correlation in A equals the correlation in B. Well, no, this one has a much lower correlation than this one. This one has a very strong correlation. This one has a very weak correlation because the data points are farther away. All right. If the sum of the square residuals in A is greater than a sum in B, the correlation will be greater. Well, no. If this is A and this is B, then this one appears A would have a lower correlation than B. So that's false. All right. If the sum of the squares residuals in A is greater than the sum of the squares in B, then the correlation will be less. That might be the case, but what happens if call this one B, and then A, we just have a whole lot more data points. If I have a whole lot more data points, then that wouldn't be true either because I just had more, if I have more data points. If I only had a few data points here, A might be a higher correlation, but be really close. So the best answer is none. All right. None of those are true. All right. Number 36. The Posen study finds that the correlation coefficient related to job satisfaction is positive 1. Which of the following is a proper conclusion? High salary causes high job satisfaction. We want to say that, but unfortunately, correlation does not prove causation. Bad word. Low salary causes low job satisfaction. Correlation does not prove causation. There's a 100% cause and effect. Correlation does not prove causation. There is a very strong relationship between salary and job satisfaction. Yeah, I like that. So we're going to go with 36 being D. Okay, that looks pretty good to me. There is a strong relationship. All right, a strong positive linear relationship. Which of the following statements about correlation is true? When R equals 0, no relationship between variables. Well, if I have a shape like this, that's a perfect parabola. There's definitely a relationship. It's just not linear. So that's false. When R equals 0.2, 20% of the variables are closely related. That's not what that means. All right. That has nothing to do with it. When R equals 1, there's a perfect cause and effect. Once again, correlation does not prove causation. A correlation close to 1 means that a linear model will give the best fit. No, it means it gave a good fit, but it's still possible a nonlinear model. Correlation doesn't check that. Remember, you have to check it with a residual plot. All right, so the only way to check that is with the residual plot. So that's false. So E, all the statements are false. Okay, when we look at this next one, it says look at the three following scatter plots, and I see exactly the same dot pattern. It's exactly the same dot pattern, but I notice the scales are different. So the scales are different, but we have the same dot plot. So which has the greatest correlation coefficient? Well, as it turns out, even though the scales are different because they have exactly the same dot pattern, they have exactly the same correlation coefficient. So D, they have the same correlation coefficient. 39. Which of the following statements about correlation R is the correlation coefficient R is incorrect? The correlation and slope of the regression line always have the same sign. Yes. If the slope is positive, the correlation is positive. If the slope is negative, the correlation is negative. So this is a true statement. That's not what we're looking for. We're looking for incorrect. A correlation of negative 0.32 and a correlation of 0.32 show the same degree of clustering around the regression line. Yep. The only difference is this has a positive slope and going up, and this has a negative slope and is going down. So that's a true statement. And again, we're looking for false statement. Correlation R measures the strength and direction only of linear association or linear relationships. That's a true statement. We're looking for false. A correlation of 0.78 indicates a relationship that is 3 times as linear as 1 of 0.26. So they said, hey, you know what? If I go 0.26 times 3, I get 0.78. But that's not what it means. All right. So that is false. That's not true. Even though we can multiply this times that and get that. That's not what it means. All right. Last one. Outliers can affect the value of the correlation. That is true. All right. And we were looking for the false. So the only one that's false is 39 is D. All right. If every man married a woman who was exactly 3 years younger than he, what would be the correlation between the ages of married men and women? Well, let's just make a chart of this. All right. Because I can explain it, but better yet, let's look at it. If he's 21, then that means she's 18. If she's 21, he's 24. If he's 25, then she's 22. If he's 40, then she's 37. So let's see what happens when we do this. So stat, edit, and we could keep doing that, but that's enough data to see what was going to happen. 18, 21, 22, 37. And for the men, 21, 24, 25. I like it that they have the men married younger women, misogynist. All right, stat, test, linear regression t-test, alpha trace. All right, so here's my equation. I ended up getting a of 3, B of 1. All right, so y hat equals 3 plus 1x. And look, my correlation is 1. Why is it 1? Because whatever x value I put in there, if I put 100, then she's going to be 103. I'm going to predict everybody's age exactly because it says exactly 3 years. All right, there was no variation. If there's no variation, then we are predicting 100%. If we're predicting 100%, it's either going to be a positive one or a negative one. And in this case, as the men get older, the women get older. So that means it's a positive. All right. So this is a positive 1. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.